In this video, I would like to deploy a machine learning model using Docker and TensorFlow Serving. You need to already have an understanding of what Docker is and what TensorFlow is and how to build a classifier and train a machine learning model. TensorFlow is a deep learning framework developed by Google, and it also provides the possibility to deploy a machine learning model which is saved in TensorFlow format. For this video, I will be using a model which predicts the fuel efficiency of late 1970s and early 1980s automobiles. Our focus in this video is not to explain how to train a model, but we want to deploy it using Docker. If you are more interested to know how the machine learning model is trained, I put a link in the description of this video to the TensorFlow official website. Perhaps I can make another video regarding how to train such a model, but now I assume that we have a trained model and we have the Protobuf file format available. So we should consider that after training a machine learning classifier, we can save the whole model with all its parameters, and TensorFlow provides us with the Protobuf format. I have put a link into where you can find it in the GitHub page of the Clever Tech Memes channel, the model which we are going to deploy in this video. So let's get started. Pulling the TensorFlow image, we write docker pull TensorFlow Serving. It will be taking a few seconds to download the image. Before that, if you require to log into your Docker, you need to write docker login and just enter your credentials. If you have entered that, then you should not have any problem downloading this TensorFlow image. Now to see our images, we write docker images, and we can see that the TensorFlow serving is available and we have it downloaded. So here I'm right click and create a new folder which I name it models. I go to this folder and now I'm creating another folder and just name it DNN model, like dense neural network model, or whatever you like to name it, it doesn't matter. Just I'm here name it DNN model, and then I want to give a version to this model because this model is version 1. It's the first trained model. We can train it further with further data or more data and improve our model based on any metric which we want and give it another version. But right now we are having the version 1, and in this version 1 I'm just taking the artifacts which are saved in the Protobuf format. I'm pasting them here so you can see that we have assets folder, we have a variables folder which contains all the variables of our model, and also this is the saved underscore model dot protobuf. TensorFlow requires a config file to serve the models. So we require to create this config file, and for doing that I'm using the Visual Studio Code editor. For doing that I have imported the folder by just opening it from the VS Code and just choosing this folder. So I have chosen already this ML folder, and I can see the models folder in my editor. So if we look into this models folder, we can see that it contains the DNN model and the version 1 in which we put all the assets of our model there. Now we create a config file by writing models.config. But this config file should be outside of this models folder, because this config file, through this config file we manage all our models. And so I'm going to the folder and just click here and just cut this models.config and put it in here. So we have this models config, however it's right now empty file, and now I'm opening this models.config in our VS Code and try to complete it based on what we require. For defining the config file, we require to define the model config list, and we write model config list, and we write config, and we give it a name to our model, and we know that the model which we have created is a saved model.pb file. So just the name is saved model. We require to specify the base path, so we write base path, and the base path on the container we will define it as models, just DNN model. And we also require to define the model platform, and the model platform here is TensorFlow. So I'm defining that, and just the parentheses are closed, so we just save the file, and this is a simple version of the model config which we require to serve the model. Now that we have created the config file, we require to create the container and run the image of TensorFlow. For doing that, we write docker run, and we use the port 8501 from our local to 8501 from the TensorFlow. This is the port in which we can communicate with HTTP requests, and we just run the Docker on detached mode. We use the mount type of bind just to mount the model from the local directory to the directory of the Docker containers. So I'm just with this %CD, I'm referring to my current directory, and I'm referring to the ML folder. I have created the folder named models, and I put all the models in this models folder, and just I'm referring to my DNN model because I want to mount it to the directory of the container. So I just want to mount it to the models directory and to the DNN folder on the container. So I'm using the mount type of bind, referring to my current directory, which is ML, and my configs reside in ml models.config, and I'm mounting it to the target, which is models.models.config. In practice, this we could just use one mount, but here I use two mounts because I prefer to put this config file outside of the models folder. I just give the container a tag name like -t TensorFlow Serving. I use also the model config file parameter to refer to the models.config file, which is on the container, and we mount it on the container. So I just hit enter, and if I write docker ps, I can see that the container is now running. To check if TensorFlow now properly serves our model, I would like to use Jupyter Notebook. I have opened the Anaconda prompt, and I just write Jupyter Notebook. Now that the notebook is open, I just create a new file here, and I just give it a name like testing API. Now I would like to test the deploy TensorFlow containerized API with a Jupyter Notebook, and I would like to use the requests and JSON libraries for sending HTTP requests. So I'm writing import requests and also import JSON, and then I'm defining one data object in Python which here we are defining the instances. We can actually send different rows or different instances to the TensorFlow API, but here I would like to send one instance of 801. I'm entering the instances which contains the features of the classifier, and this is from a test set, so I'm defining a data object here. Then I'm converting this Python object to a JSON, so write JSON.dumps data, and then I'm defining a URL. Currently the model is deployed locally, so I'm using the local host as the URL and using the port 8501, and this is the first version of our model, and we are calling to the models. Saved model is the name of our model. Saved model is the name of our model, and then we are referring to different versions. Here we have version 1, and then we want to do a prediction, and we define headers for our HTTP request. We want to send just JSON. We want to send JSON, and now, and also we are receiving a JSON response after sending the post request, and we are, as a data, we are sending the data.json, which contains this instance, which includes all these features. These features you can find it here in the link which I've shared with you. We want to predict this MPG, and the features are the cylinders and, for example, displacement, horsepower, and so on. So we have 9 features here and 1 label. I here define the one instance with these 9 features and sending a post request. So we hit enter, and then we have the prediction value returned from the API. We are sure now that the API is working and is up and running. But what now if we have 2 different versions of the model trained? Suppose that after some time we are having more data and we would like to train our model again and improve its accuracy and deploy a new version of our model. So we need to apply some changes to the configuration file and create another containerized version of the application. So let's apply a stable version, a Canary version for our deployment. For doing that, I'm going back to my VS Code and try to modify it to include also a stable version and also a Canary version. Here I can add a model version policy to the configuration. Model version policy, I'm defining a model version policy and telling that with this specific keyword we can define the versions, like versions 1 and versions 2. Suppose that we want to have a stable version and a Canary version. We can assign labels to our deployed models, like with this version labels we can define the labels and we can specify them by a key. Here I'm using a stable keyword with the value of 1 because this is the first model, and also I can define another label, but version labels, and give it key of Canary and the value of 2. So what does this mean? So it means that we can have 2 models, one is stable and the other is Canary. If we have groups of customers in which we want to use our stable version, then we can basically deploy this stable model, and for some other customers in which we want to use a test model or like a temporary model, we can use this version of the trained machine learning classifier. We created this DNN model inside our models folder, and we can see that it has a version 1. And if I just make a copy from 1 and paste here, and I start renaming it, and to model 2, I want to rename it to model 2. So I'm just renaming it to model 2. Suppose that this model 2 is different than model 1, just as an assumption. So we want to deploy a new version of our model now, and because we have two different models in DNN model, in the configuration file we define versions, and we just say that the first version of the model this is the stable version, and the second version of the model is the Canary version. So let's continue to see how we can do this in TensorFlow and Docker. For doing that, I'm using exactly the same command in which we used to containerize our application. We need to change this command a little bit to allow version models, and we use a parameter named allow version labels for unavailable models equals to true. And then I can enter and create a new model out of this. So yes, because the port is already allocated, this command failed, so I just I have this container up and running, so I'm just using Docker stop. I use Docker stop to stop this container. So I guess I have used one parenthesis wrongly here. I should close the model version policy and just separately use this version labels inside the config file. So I'm saving the file, and now I'm trying to run it again. Just create the containerized API and just check if we have. Yes, it is up and running now. For the testing of the API, we just need to change these versions to labels and this one to Canary or stable. So if we use the Canary and if we use the stable, we can see that we are receiving back some results. Here our models are the same, however this has been just for demonstration purposes, and basically these two models can be different. One model, the Canary model, can be a test model in which we have performed some improvement, and the stable models are the model which we would like to use reliably for rendering results to customers, for example. Okay guys, in this video I showed you how to deploy a trained TensorFlow model using Docker. We have deployed the model and tested the API using HTTP requests sent in Jupyter. Also, I showed you how you can separate the users of your API by defining a stable model and a Canary model. I hope you have enjoyed this video. If you have not yet subscribed to the channel, please do so to get the latest updates. Thank you very much for your attention, and see you next time.